Howdy, my name is Justin. Today we're going to be making a bubble sorter. This is a great way to really start to understand how sorting algorithms work. So we're going to be working in C++. That's what I'm most familiar with right now, but this can be implemented in other languages as well. So let's just go ahead and get started. I went ahead and I created this array, and what we're going to do is we're going to sort this array out, okay? One thing you'll notice is that it is out of order. We are going to be making a ascending sort, but the same principle applies whether you're doing ascending or descending or alphabetical. You'll just have to change a couple of constraints. So conceptually, the way a bubble sorter works is it's essentially running through multiple loops of this array, and every time it is looking at it's looking at two integers at a time, and it's asking this is a ascending sort. So it's going to look at this and say, okay, is 45 larger than 98? Oh, no, it's not. Okay, let's move on. Is 98 larger than 21? Yes. Okay, let's swap these two values. So now you'll have the 98 over here, and then it's going to move on and keep asking this question. And again, it's just looking at two variables, comparing them and swapping them if they're in the wrong order. So it's going to go through that once. And one key thing to understand is that after it goes through once, we know that 98 is going to be 98, just for reference, is the largest number here. It's going to be at the end here. Okay, and that's going to be helpful because since we know that at the end of this first pass through, the largest number is going to be at the end, that means that we don't have to reconsider this 98 again. We know it's in the right spot at that point by the time it goes through the first time. Once it goes through the second time, then the second largest number is going to be in this second place right here, or their second to last place, and so on and so forth. So conceptually, that's how this works. Now let's actually get into implementing it. So again, I'm using C++. I am including IOStream because we're going to be doing some printing to the console. I just like to use this shortcut using the standard namespace just to cut down on characters. Okay, so we're going to put most of our logic in this main function here. But just to make things simple, what I'm going to do is I'm going to put in a function that's going to allow us to actually visualize this array through every step of the process. You don't need to worry about this. This is just a really simple function. I'll just show it to you right here. It's called display R. All it does is it takes in the array and the size of the array, and then it loops through it and prints out all the values. I'm just going to use this so that I can show you at every step of the process where all of our values are. Okay, so as you can see in this display R function, what it does is it takes the array and it looks at the size, and it just has this simple for loop. All it's doing is it's looping through every single value and then just printing out the value at that address, at that position in the array, and then adding a comma to it. Unless it's the last value, then it's just printing that out without the comma. It just looks nicer that way. So let's go ahead and just run it just to see how it works. So I'm going to do display array, and then I'm going to put in this unsorted array. Now I know that there are 8 integers in this array, so I can just put in 8 for the size, and there you go. But if I wanted to, say, add another value to this array without having to change this 8 right here, I do have another option, which is to dynamically figure out the size of this array. The way to do that in C++ is we're going to look at the size of the array, so size of unsorted array, and then we're going to divide it by the size of any of the values in the array. And I'll explain why. Okay, so real quick, the reason why we're doing this is because size of unsorted array, it's looking at how many bytes are in unsorted array. It's not looking at how many values. So we know how many bytes are in the entire array. So then we need to look at how much is in just one of the values. If we divide this by that, it's going to get us a number because if you multiply how many bytes are in a single integer times the number of values, you're going to get this here, which is again, the number of bytes in the entire array. Again, if you want to, you can just hard code this, but I just wanted to show you that as well. And as you can see in my print statement here, we do have all of these values here. Awesome. Okay, let's start our bubble sorter. Now, just to make my code a little bit cleaner, and because we're going to reuse this value, I'm going to make a new integer called unsorted array size, and we're going to set that equal to this right here. Okay, and then we'll just reference it right there. And never forget your semicolons. Okay, good, everything's still running. So here in the bubble sorter section, we are going to be making a pair of for loops. These are going to be nested for loops, meaning that one will be inside the other. And I will show you exactly why we are doing that in just a second. So let's make this outermost one. So make this a for loop. We're going to have this be int I. We're going to start at 0. Now, how many times are we going to go through this outermost loop? Well, because what we'll be doing is comparing this value with the next value, we actually don't want to keep going and start with this value and try to compare the next value because it doesn't exist. We're going to run into issues that way. So we're actually going to continue as long as I is less than the size. And oh, sorry, we made a array for that, or sorry, an integer for that. So that's the size. Again, that's going to be 8 in this scenario, minus 1. That way we aren't going out of bounds here. And then we're just going to increment through this. Okay, so now let's make this inner for loop. So we're going to do for int, let's do j. It's the next letter, makes sense. Set that equal to 0. Now here's where it gets interesting. Now for this inner loop, as opposed to the outer loop, this inner loop is the one that's going to be running the most frequently. The outer loop is going to let us reset and go back to the beginning of the array as we're going, but this inner loop is really where the comparison is happening. Now, as I mentioned earlier, after the first iteration through this array, we know that 98 is going to reach the very end of this array. That means that we can actually save time by not looping through this entire thing over and over and over. On the second iteration, what we can do is we can take a look at these values and these values and so on, but we don't need to go all the way to the end here because we know that this value will already be in the correct position. And then on the next go around, we'll know that two of these integers will be in the correct position. So essentially, every time we loop through this entire array, we can do one less comparison of two values at a time because we know that these values, and it depends on how many loops we've done, these values will be in the right position. Okay, so how do we actually tell our computer that? The way we do that is we're going to check to make sure that j is less than the unsorted array size. Again, that's going to be 8. We're going to subtract 1, and then we're also going to subtract I. Okay? Again, what this does for us is it makes sure that we're not making unnecessary comparisons where we already know that the numbers are in the right spot. Okay, so now in this inner loop, this is where we are doing our comparison. So let's make an if statement. If the array, so unsorted array, at spot j is greater than the next value in this list, and we can find that next value by looking at j plus 1. I don't like that spacing. We're going to do that. Okay. Then execute this code right here. This is our swap code. We need to swap these two values in this array. How do we do that? The easiest way to do it is, let's look at unsorted array at j. Now this should be set to what is already at unsorted array at j plus 1. Okay, great. Now this first value is equal to what is at the second value. Don't forget the semicolon. However, we can't just go in and say, okay, unsorted array at j plus 1, j plus 1 is equal to what was at unsorted array j. Why is that? The reason is because that right now j, or this first value, is set to the second value. So this would really do nothing, okay? So what we need is, what we actually want is for this, which represents the second value in our array, we want it to be assigned to what this value right here used to be. So the easiest way to do that is we're going to make a temporary value and have that set equal to unsorted array at spot j. Okay, so this temp value is what we're going to put into the second position. So just to review, in this inner for loop, what we're doing is we're looking at the first two values. So in this case, it's 45 and 98, and seeing, is 45 greater than 98? In this case, no. So on the next for loop, we would be looking at these two values. Is 98 greater than 21? Yes. Okay, in that case, we're going to set 98 equal to this temp value. Then we're going to take the spot where 98 was and set it equal to where 21 is. So basically 21 would be right here. And then where this 21 is right now, we're going to set it equal to that temporary value that we set up earlier, which is 98. So essentially we've just swapped these two values. That's just how you have to do it. Okay, and then after we've made this bubble sorter, we're going to display the array, unsorted array with the unsorted array size, because remember we do have to pass in both of these arguments into this display array function. And if we're lucky, we hit the run button and look at that. This is a sorted array. This is exactly what we wanted. So this still might not make sense to you, and that's okay. It did not make sense to me the first time either. What does help though is really getting a better understanding of each step of this process. So we're going to do that, and I highly encourage you to do this with your other programs as well. I want to know when this inner loop is running versus this outer loop. This was the hardest concept for me to really understand is, why are we subtracting -1 minus I in this scenario? And in what cases is this for loop running versus this one? So let's just add some couts here. So I'm going to have this one say inner loop running. Oops. And then let's have one run for this outer loop as well. Okay. Another thing we can do that might be helpful is after each step, print out where we are. Essentially, every time it goes through, let's see what this looks like, right? So we know that swaps are only happening inside of this if statement. So at the end, I'm just going to have it display the array. We're going to have the array be the unsorted array, which is not a great name because it becomes sorted, but that's okay. And array size for the size. And okay, now we have some better debugging here. Let's see how this changes our results. Awesome. Okay, we have a lot more information now. So let's start at the top. Okay, so right here, this is the array that we're starting out with. Then we're going to run our outer loop. And then our inner loop runs, and then nothing happens. Another inner loop runs. And remember, the reason is because it's looking at these first two values and swapping them if 45 was greater than 98. It isn't. So what happens is it says, oh, it's not. It does not execute the if statement that we were looking at, and instead it moves on to the next inner loop. So this next inner loop is going to do the same thing, but remember, we have an incrementer on our for loop. So now it's looking at these two values, 98 and 21, and it says, wait a minute, 98 is greater than 21, so let's swap these. And if you look, that's exactly what happened, okay? 45, 21, 98. And again, you're going to realize that 98 is going to be pushed over to the right throughout this first outer loop. See, look here, look at this outer loop right here. We don't see another outer loop run until later here. So all through here, these are all our inner loops, okay? That's really where the the processing is going on, where it's making those comparisons, okay? So we push the 98 right here, okay? Now what it's gonna do is it's gonna go through this, go through the next pair of values. It's gonna compare 98 and 63, and it's gonna say, oh, yep, looks like 98 is greater than 63. So that's exactly what happens. The inner loop runs and it swaps 98 and 63. I'm not going to keep going down, but essentially, look, watch this 98. It keeps swapping over to the right, okay? And then by the end, 98, before the next outer loop is run, 98 is all the way at the end here, okay? That's key. That's why in our program, we are able to say for this loop, this inner loop, you don't need to go that far. All you need to do is you need to go the entire size of the array minus 1, because again, we don't need to, or at least we don't want to compare the last value with the next value, which either doesn't exist or isn't helpful. So it's the same one, and then minus I, because I keeps track of how many outer loops have gone. Every outer loop, that means there's one less value we need to check, because that value, there's a value at the very end now, or 1 away from the end or 2 away from the end as you keep going through the outer loops, that we don't need to check anymore because it's been placed there at the end. Going back here, so we have this second outer loop right here. We have a bunch of some inner loops run. It keeps checking. We have another outer loop here, and then another outer loop. And essentially what you're seeing is that after every outer loop, we don't have to run through as many iterations as we did earlier. So as we do more outer loops, we have to do less and less inner loops because we're doing that subtraction in the for loop. And here at the end, you have our sorted array. I hope that this video was helpful for you in understanding how bubble sorters work. Once you get it, it's actually kind of beautiful how you can just that easily, or with that little logic, just sort an entire array. But if you found this video helpful, please give me a thumbs up on YouTube and subscribe to the channel or leave a comment. I don't know, just boost my engagement somehow. Thank you.